Color has always been an intriguing concept to me, and understanding how we perceive color has never been clear. In Chapter 9, when learning about color perception, I was very interested and felt like I was learning a lot and felt much less confused than I originally did before. Color perception is closely linked to emotion, identity, memory, and culture, which is something I never really realized before. Understanding how we perceive color reveals insights into how our brains interpret the world and how colors influence our thoughts and behaviors. The variation in color perception across individuals and species showcases the complexity and beauty of how our brains process light into rich and nuanced color. Perception of color is essential to how humans experience and interact with the world, influenced by biological, psychological, and ecological factors. It serves various key functions including visual identification, depth and contrast perception, emotional influence, signaling and communication, aesthetic expression, navigational cues, survival, memory, and learning, and health and well-being. Color also helps with perceptual organization by increasing contrast, making objects easier to detect and recognize, especially when they are appropriately colored or familiar. Additionally, color can influence the perception of emotions, such as interpreting facial expressions with green, often indicating disgust, or red, which often indicates anger. Overall, perceiving color is vital for recognition, survival, emotional responses, and communication, all of which are critical for interacting with both the environment and us. Color and light are closely linked, and understanding their relationship is key to explaining how we perceive color. Color arises from the interaction between light and objects, with the color we perceive being determined by the wavelengths of light reflected or transmitted to our eyes. Early on, people believed prisms added color to light, but Isaac Newton disproved this by showing that white light is a mixture of different colored lights. He demonstrated that a prism separates white light into its individual components, and the color of each beam is determined by its unique physical properties. Later in the 19th century, scientists confirmed that colors correspond to specific wavelengths of light. Our perception of color depends on the combination of these wavelengths, and when mixed, they create new colors. The brightness of the light source also affects how we perceive color. Ultimately, the wavelengths of light, along with how light interacts with objects and is processed by our eyes, the color of objects is primarily determined by the wavelengths of light that are reflected into our eyes. Chromatic colors are blue, green, and red occur when certain wavelengths are reflected more than others, while achromatic colors, such as white, gray, and black, result from the equal reflection of all wavelengths. Objects typically don't reflect a single wavelength. Instead, they reflect a mix of wavelengths.